Just going to run the loop, so I'll do it.
It is on at the moment. We are live streaming on YouTube.
So just let me actually live streaming right now, or you?
Yes.
Okay, will you introduce it? Because I'm going to disappear. I need to use the little voice room a second.
Okay.
So, we are live streaming. So, give me 1 second. Is the projector working?
It must have switch it on.
Does help.
Yeah, that does help.
Give me 1 second. I'll be 1 second. You can do your introduction.
Right, guys, welcome. All those guys that came last, put your hands on. It's their fault that we delayed. It's the second row over here. No, jokes aside, guys, thank you so much. We don't often get the opportunity to have sessions like this when we have firstly the majority shareholder of Sunsynk, being Keith Goch. Many of you would have probably been following and seen one or two of his videos on the YouTube videos, but he's also fundamentally the designer of the LK system that we'll be looking at today. So no question is too technical. He really is the guy that understands the system the best. So really to give you an overview of our new products. Really imminent with launching. So by the end of next week, most of the distributors will be able to be giving you final pricing and so on the new product. So we're super excited about it. So and again, thanks for your time. I mean, it's a middle of a week. I understand everybody's busy, but we appreciate your time. So again, guys, please, questions. We've had other sessions. Guys have asked really technical questions, so nothing's off the cards. And welcome to our new offices. Those that haven't been here, those that were in our old offices. I don't know who'd ever visited us at the old offices. We had three little sections of a building. Was extremely challenging logistically and so on. So really the move here is we got about 2.5 square meters of warehouse space just at the back here, and we've rebuilt all our desks and service repair desks. So we do have a little bit of a backlog at the moment. I'm not even going to try and lie because of the move. We lost about 4 to 6 weeks in the move, but we're getting that under control very quickly now. So yeah, this is our new office, so welcome. We're going to do a lot more training there with Dricus and them at the back. We're going to be building a really nice demo area. So if you want to bring your customers around and come and show them the products, and it will be live products. We're going to have live products over here. So at the Solar and Storage Show in 2 weeks' time, we're hoping to land our first power hub this week. Well, it will land this week. It's in the air at the moment. That's the it's a dummy version of it, and then we're really holding thumbs at the moment. Our first full unit is also on the sea, but at the moment it looks like that might only land in South Africa on the 23rd, and then we've got to get it up from Cape Town into the show. So it's going to be really touch and go. So have a look. The dummy unit is going to be on the ARB stand, and then the full unit will be on our stand if touch wood, if it gets here in time. So yeah, where's Keith? Any questions up front before we start with LK? Anything about Sunsynk, the organization?
Neil, so you guys pretty much going to be following the same strategy through distributors in terms of the sale of both the power hubs and also your bigger systems?
Probably, yes. I say probably because we are in discussion currently with the distributors on what that route to market will look like. But at the moment, yes, will be through distributors. And there would have to be a good reason for us not to do that. So we're looking at various options, which I don't really want to go into detail because nothing's decided.
Yeah.
potentially large projects, I don't know. We
And then, I mean, as stockists, you're relying on them to carry stock?
absolutely, yes.
Distributors
Absolutely. So distributors that are going to be part of the LK journey we're going to walk, the CNI journey, will for sure be expected to keep stock. Absolutely.
Okay.
So obviously not on the containerized units. So your bigger stuff, what we call integrators, we'll share more with you today. So 1 megawatt and 2 megawatt units, I mean, those are going to be to order. But you'll see today we talk about what we call modular systems.
Yeah.
And then the power hubs, for sure, will be expected to keep stock, yes. Yeah.
Okay. And how many channels are you looking at potentially in the market?
Our current 4 channels.
The 4, and those are?
ARB, all power down in East London. Get off grid, sitting in front of us here. ARB, a lot of their guys are also here today. And then Siegen.
And Siege,
Siegen Solar. No, 4.
4.
ARB, all power, get off grid, Siegen.
Okay.
Yeah. But yes, people are partaking, or as I say, not partaking. People that are gonna walk the journey with us will be required to keep stock. Yeah.
Okay.
Yeah. So as soon as the first one's are ready, and as I say, the modular systems is sort of probably what's delaying it a bit now. But we'll share more with you about the modular systems now, and then as soon as by the end of next week, I reckon we'll be done with everything. Yeah. But I'm not going to talk about modular. I'm going to let Keith share with you guys about that. Yeah.
That's the exciting part. But you guys have been missing the product range.
100%. So maybe on top of that, we will also launch at Solar. If you come around, we will launch our full range of string inverters. We'll have from a 25 watt, what we're going to do, we're going to bring 25 kilowatt, 50, 80, and 125 kilowatt and 136 kilowatt string inverters we'll have, okay? We will also, it won't be at the show, but it will be launched. I don't think, Drickus, we don't have the 125 hybrid at the show, eh? The new one, no. So currently we only go to an 80 kilowatt hybrid. So we'll imminent launching the 125 kilowatt hybrid as well.
Okay.
Yeah.
And same function, is that, are we discussing that today?
No, that's not part of today. So reach out to myself or Battis, maybe Battis. Just I don't know if has everybody met Battis and Drickus, but Drickus is our marketing manager, standing at the back, and Battis recently joined us. And he's going to be looking after all of our CNI side of the business. So please, if you haven't got his card, get a hold of his card. Any questions on the products you see today, the 125 kilowatt hybrid, Steve, all those kind of things, have a chat with him, and then we can take it from there. I don't even have the data sheet yet on that 125. Okay. As soon as I get the data sheets, then we can get it through.
The functionality is the same as the 50 and
50, 80, 125, going to be pretty much the same, yeah. Good. So I'm going to hand over to Keith.
Right. So, well, I tell you what, I normally say everywhere I go it's raining. If you ever follow me on Facebook, but it's a beautiful day today. I did arrive in South Africa when I first arrived, and it was absolutely belting it down. Everyone said, "Come to South Africa. The weather's wonderful." And for the first week, it was absolutely freezing and cold. So anyway, we're live streaming. So we're going live, which is don't often do, but hopefully don't make any mistakes. So I've got to be careful what I play because there's no copyright on anything. So, but yeah, I'm going to present to you where we're up to as Sunsynk. And there's a lot of things changing. And we're basically going to present about the LK range. So a little bit of background. People ask where we are, where we're coming from, and where's Sunsynk. And, you know, we're in many, many countries. We obviously start off in Hong Kong. And it's a quick idea where we're up to. East Africa. We're in the UK. We're doing very well in the UK. We're in Ireland. We're in the Netherlands. Okay, nice. We're in Poland, Pakistan, India, Australia, Spain, Germany, France, Middle East, Israel. Some of you guys may have recognized the guy in Israel. China, of course. The US of A. So South America, Nigeria, the Congo, Uzbekistan, Tanzania, from Tanzania, Hungary, Ukraine, many Philippines, and of course South Africa. This is our new office. We've just moved into this office, so we've upgraded. So we've had an upgrade from where we were before. We were in 3 little units. So it's a little bit of a background where we are. So we're going to talk about something different. Obviously, I'm going to jump on this fire side because so it's not my video. So, but basically, I'm going to talk about why our products are better and about why we are safer and the various problems. I do hear an awful lot about issues with fires and stuff on containers and container batteries, but our technology is different. We use low density batteries. We don't use super duper high density stuff. We use air cooled. I honestly believe the way we do it is better than the way other people do it. And we can explain the reasons why, and I'll talk about our product, what it is modular, and why it is better. So let's start at the beginning. Obviously, I'm not going to teach you guys about the savings of power, but all of our products, the LK range, is designed specifically for the UK and the South African markets. We're a British company, and we're also a South African company. So I would always refer to us as British South African business. Both markets are very important to us. We've been in South Africa a long time. Sunsynk, we're 25 years old. So we're a 25-year-old company. We've been going a long time. This year is our 25th anniversary. It's quite proud of it. And so, I'm holding the microphone, but we're 25 years old. And I'm sure our marketing department will be doing lots and lots of things about celebration for our 25th. But it's important, and we've been around a long time. It's been the same company. So we changed name. We used to be called Global Tech China Limited, and we changed it and that was a long, long time ago. And Sunsynk was registered a long time. We've been making inverters a long time. But our products are designed for the British climate. It's all about the British weather, the South African weather, and our products are we're designed for the real world. It's designed to last. And I mentioned about the weather because it's important because, in the UK, for example, we have regulations that every inverter, every system has to be mounted outside. You can't mount it indoors. You have to mount it externally. And there's certain safety regulations. And we have our own problems in the UK because we have to operate things at minus 20. I don't think you have that problem here. So, but we do get cold spells in the UK, and the last thing you want, if it's very cold at night, the last thing you want is your batteries failing. So it's really important. Talking about the LK. The LK is a modular system, so everything is modular. And as I flick through these things, and what you can see on here is I'm looking at a standard inverter. So this is our normal inverter, and this is a rack mount inverter, and it's basically the same thing. The same components. You have a PCS in an inverter. You have an STS, a static transfer switch. You obviously have relays, which is basically an STS because it synchronizes with the AC. So it is exactly the same thing. You have your MPPTs, you have your MPPT modules. And of course, the whole thing is controlled by an EMS, which on a standard inverter, we will call the EMI or the human interface or user interface, what you want to call it. But basically, that's the thing that controls it. And on the LK type product is done by an EMS, an energy management system. But it controls the whole system. It controls everything. So it's really important. It's really quite important. And to understand, the one thing I will explain over and over again is our LK range consists of just 3 modules. Whether you're going to be looking at the indicator, big indicator product, whether you're going to be looking at a power hub, or if you're going to look at the separate units, they're all just 3 modules. You have an MPPT, you have a PCS, you have an STS. Everything is built from that. And of course, the whole thing is controlled by your EMS, which basically we run on the PCs. They're industrial PCs, so IPC. And that's the whole thing is run that way. Going forward, this is actually what the things look like. This is a power hub. And we'll start looking at power hub. And this is probably a little not the very basic, and I'm showing the very basic on another picture. But you can see here, this is an on-grid or off-grid. So if you're using an on-grid or off-grid, you don't need to have the static transfer switch. So what you've got here is you've got your grid, you've got your inverter, couples here, your MPPT, and your batteries. It's very, very simple. You notice on here, there's no changeover switch. So basically the static transfer switch, and I'll show you the static transfer switch, basically is a disconnect from the mains. People say, how fast your changeover? Well, if the inverter is in discharge mode, there's no changeover because you just disconnect on the STS. There's no actual changeover, it's a disconnect. So it doesn't change over. The STS operates very quickly, but you're not having like the old fashioned where you've got a relay swapping things across. It doesn't exist. The only time you have a changeover is if the inverter is in a charge mode and you want to discharge, because the inverters are reversible. So exactly the same as a normal hybrid inverter, PCS is reversible, it goes one way or the other. And so, of course, if the inverter is in a charging mode, it has to reverse. So you then will have a very, very fast, it's milliseconds, very fast changeover. If it is in discharge mode, there's no changeover. So it depends on where it is. The heart of it is the EMS. This is the EMS, this is the energy management system. You know, lots of people, I'll put this microphone in so we record it. Lots of people make, and there are quite a few, you see various systems, modular systems. But modular system, when you got a PCS or an STS or an MPPT in its modular form, its bare bone form, is probably not much use because you'll pick it up, it's dumb because the thing can't do, it doesn't have a screen on it. It doesn't have any, it has to be controlled by something. And so the EMS will bring the whole lot together. So it's as if it's a hybrid inverter. It can tell when to charge, if discharge, it can control the voltage, everything is controlled by the EMS. So you have a local EMS that actually controls everything. So let me go a bit forward. This is actually, I reversed, the screen's the wrong way around actually. So this is showing the inverter, just an inversion of battery in its simplest form. So let me go forward. Right, okay, so this is actually a on-off-grid system. This is actually in production, and I'll use this because obviously I can't carry things here, so I've got a number of videos which I'll share with you. So this is actually the system, let me explain it. This is basically a power hub. This is a 215 power hub on and off grid. So let me play this video and you can get a little bit of an understanding how the modules work. Okay, so we're rock and rolling. Okay, promise to start doing some more of the training videos for the PCS, Power Hub, LK range, our range. So let me explain. We're actually in the production area, and it's better to show you this one because it's partly dismantled and explain what the various components are and what we can do. So of course here, this is a 215 kilowatt hour. We have 250 kilowatt hour units. They've got air blowers onto each of the batteries. We've got the HVAC unit sitting into the door, and you can see the airflow, how the airflow operates. It works a treat, absolutely no issues. But let's focus more on the unit itself. So on the bottom here, on the power hub, you've got 4 channels. They are your MPPT inputs. They've all got separate DC isolators. So on the MPPT inputs, they are quite high power, and you would have to use a combiner box with diodes. I wouldn't suggest you go and connect the solar panels directly to them. You've definitely got to. So each unit is, say, a 60 kilowatt MPPT. Then you would need 5 per channel. So it's basically a 10 channel combiner box split into 2 with diodes, with the protection surge and everything. So you definitely need to use that. And this one is actually generator input, but this is direct connection. You have to physically switch. You have to override it. It's done by a breaker. What we're intended to do is connect this unit here to, on the top here, we're going to fit in an additional PCS. So the generator port connects directly to a secondary PCS that connects directly to the DC bus. Why would we do that? Simple. That means if that generator runs, and the generator is running at, say, 45 or 48 hertz, or the frequency is unstable, it will still charge the batteries. And amazingly, you can run the grid and the generator be at different frequencies at the same time. The rest of the thing, this is your MPPT module. We have space to add additional MPPT module if you want to. This has got 100 kilowatt. These are 50 kilowatt each, and this particular unit has 100 kilowatt MPPT, which is split into 4 channels. Here, which hasn't been installed yet, is actually the PCS, the Power Control System module, and that slots in here. And here is we've got the STS. The whole thing is actually connected to a transformer. Come and have a look around the back. So here, you see here the guy's working on the transformer, and this is the transformer. It's transformer coupled. Right, that's a new word from me. Transformer, galvanically isolated. That's supposed to be using it. So basically, what I was trying to show on here is the modular, the way the system is. So this particular unit is used for on and off grid. It's got an STS, got a static transfer switch, which is this unit here. It hasn't got the PCS fitted at the moment, but you can actually see the MPPT modules, you see the batteries. The beauty of it is everything is modular. So if you ever have a problem, you can swap a particular module, it's serviceable. And that's the most important thing about what we talk about on our LK range, is the whole thing is serviceable. But the most important thing is the software. We've got some very, very nice software, some clever software, the way it all pulls together. And let me continue. So obviously we're looking at units which are just on grid or just off grid. And the main difference between just an on grid or off grid, you see there's very little in here because it's just straight connected. And so often people compare on power hubs. They will say, oh, what's the price? And they'll compare an on or an off grid power hub as opposed to something that you can use as a UPS and a lot of other features. And one of the nice features that we've got on power hubs is you can run a generator at the same time. So you might be having grid and a generator, and it could be, the frequencies don't need to lock. So the generator can be charging a battery, and also you can use a small, if you may use a 50 kVA generator, but you might have a 100 kVA load at some point, then the generator can directly charge it, directly DC couple the batteries. It can charge the batteries directly. There's no complicated changeovers, because so often with generators is when they change over, and if they've got to supply the load, so if the generator's got to charge the batteries and provide the load at the same time, the generator comes into sync, the load hits the generator slows down because the engine of slows right down, goes out of sync, the frequency moves, thing drops out, and it's a problem. And it can go over and over and over again. I see somebody nodding at the back. It happens. Yeah, it's happened to me. It is so frustrating. And it is so by doing it the way we do it here on the power hubs, it can't happen. It works independently. So you've got a nice noisy generator that can't whatever. We can take whatever power. If the generator frequency is running at 47 hertz, it doesn't matter. It will still output DC, and it will go straight DC straight onto the line. So that's an important feature. It's a really, really important feature. And of course, I'm going to jump through those other ones. So it's just all I was showing on those videos, and those videos all are on YouTube, is to show the difference between on-grid, off-grid, and the smaller power hubs. Those power hubs don't do us justice because they were the original ones. And I think it's a standard case that a lot of people using the sort of same generic metal cases, but we didn't want to do that. And I looked at it and I said to David, who's our CTO, who's an industrial designer, who will probably present in a short while, I said, we want something different. We don't want to be the same. So I said, David, please go away, come back with something amazing. I want it to look amazing. And that's what we're trying to do. We also try to look at the problems and different things, and that's what we finally come up with. So this is what...
Sorry, if you go back there, all of those are different options, like the aux PCS to take a generator input.
Correct.
It's a different option.
Yeah, it's an option. But you can see, sorry, I jumped there. So you can see the auxiliary PCS here. You can, but there's when I go a bit further on, there's other things that you can do which makes the product really nice. But yes, you can see here, generated through an aux directly through the battery management units. So the batteries here, MPPT batteries are sitting in the middle here. That's a mistake. That shouldn't be on there, that load. The load is here. That should be just grid. It's a mistake on the STS. So it's only on the drawing. I apologize for that.
AC bus came in, which let's say there's a generator upstream of the unit. So
Yeah.
in the complex, there's a generator. And you are wanting to basically use the same AC bus for the generator and also for the grid coming in. Is that possible?
You'd have to go through so if you want to, so this can run if you run it from auxiliary is the best way because it's tidy. Okay. And I mean tidy in as much as it will get rid of all the noise on the generator and but you can do two ways. So one, you can use a static transfer switch if you want to, but it means the generator's got to take, the unit's got to take the full load of the generator's got to take the full load. Or you can actually, using most generators got an ATS on them, so you can run the AC through the ATS of the generator. Yeah. Be careful. One of the things to be careful about is what I was showing, we protect the export because it's a common bus, and we protect the export using a meter, we don't use CT cores on the big stuff now, so it's done by a meter. There is a possibility for it to backfeed. So we have to be very, very careful on that, especially with a generator, because the last thing you want to do is backfeed the power into a generator and blow a generator up. If you are directly connecting a generator to the AC bus on a hybrid inverter that can export, then make sure the generator is big enough. I'm a little bit with some of these inverter generators, some of these new design where the engine is running much faster and the inverter slows it down. It's just basically to reduce the size of the units. In other words, you can make a bigger kilowatt generator with a smaller engine because the engine's revving faster. Some of those with electronics, you have to be careful of, because if you backfeed, you will damage the generator. If you're using a traditional generator, a nice big heavy generator, as long as the generator is big enough, don't keep it too, I say to people, don't keep it too tight. If you've got a 1 megawatt unit, don't go and put a 500 kVA genset on it. Otherwise, you're going to get a problem, because it backfeed, it will damage the generator for sure. You need to make sure you're matching. Generally, if you put it on an OGS one, you can't backfeed. It will never backfeed. So it depends on how you configure it. Anything else? Okay, so this is talking about the power hubs, and these are what we developed. This actually is a rendering, but the real product looks almost absolutely identical, and then I'll start talking about that. But I'm going to move forward. I'm going to start talking about a modular system. So I've talked about Power Hub, which is the Power Hub is basically an all-in-one unit with all the batteries. But then we have modular systems, and we have several modular systems. So in its simplest form, we have here, which is a simple on-grid module, which is a 500 kilowatt PCS, 500 kilowatt MPPT. You can have it with or without transformers on grid. So this one shows, because there's no STS on this one. Solar panels work pretty much like a big string inverter in that respect. So you have solar panels, it can export if you want to, if it doesn't have to export. It's like a big string inverter, except it can store the energy in the batteries. You can use it with or without transformer. Generally in South Africa, you don't need transformer to couple it. The reason why a lot of inverters tend to use transformers is on the bigger stuff, they output in delta format. And so if you output on the inverter, on the PCS, you've got delta, you have to use a transformer to convert it to star, or Y connection, whatever you call it, because you haven't got neutral. And so so many of them use a delta to star transformer. Our unit can output either, so we have the options, you can buy it in a delta format, or you can buy it in a star format. I would suggest probably most applications in South Africa, you would output in a star format. The only time you might consider a delta is if you're going to put it straight onto an 11 kV line or something like that, but you're still going to use a transformer anyway. So only time I would consider that, but generally you don't need it. The units are very, very stable. They are galvanically, we have an isolation part of the boards, so they are isolated. So there is an isolation. This is one thing about it, and they do have transformers in it because of the switch mode power supply. So the configuration of it, but in a very simple form, is that, and that's using an all-in-one power hub, all-in-one unit. It's not a power hub because there's no batteries in it. The batteries are separate, but it's like 0.5 megawatt. And what we're going to do is we're going to offer this unit in its skeleton form. So there'll be a skeleton version, which will be a 125, but it's 125 piece MPPT, 125 PCS in one cabinet. It's all in one unit. And we've got the modules, and the modules can be supplied, and you can build it up to 0.5 megawatt. So this is its simplest form. We can add, so this is obviously showing the same thing with an STS. It's an all-in-one unit, and we've got the STS sitting in there. As I go forward, there's different options. So this is where we're using a larger unit. So this is where you're using just an MPPT module, just a PCS cabinet. So it's a single cabinet with just PCS, single cabinet with just MPPT. The PCS has the AC equipment on it, has your breakers, everything else. The MPPT is just DC coupled, and also on this one we'll also have a DC breaker. So they're all coupled by DC cables. You'll see there's a big heavy DC breakers in the cabinets themselves. And so the wiring of it is really, really simple. You just basically, you're going to connect your AC stuff and your grid and everything else. You're going to, from here, you'll have a cable which will connect to the battery and to here. And you've got the batteries have got breakers. These have got breakers, DC breakers. So everything is really, really safe. Your array, you will put through a combiner box. So you've got an MPPT. This would actually have a huge combiner box because you need the combiner, because you've got a lot of channels. If you're going to go for 1 million watts, then you need to use, and you can use a single combiner box, or you can take the cables in heavy cables and have the combiner boxes remotely. But you still, there are regulations. I know you're not allowed more than 1,000 volts. Understanding the PCSs, the power conversions, and the MPPT. So the power conversion unit and the MPPT operates slightly differently. So the MPPT has a boost converter, a boost. That means it doesn't have a buck. So the battery voltage is the highest point of the voltage. So if the battery is a 900 volts, the MPPT can't be higher than the 900 volt. It can't. And it also works out, and most of the similar systems on the market do similar, the big old-fashioned systems. The reason it's ceiling is because of the battery level. So it can take a lower voltage, 400, and it'll bring it up to the 900 volts, which is the battery. But if you went 1,000 volts, it can't go down. But in South Africa, you've got a limit of a 1,000 volt limit line, so you're okay, you're fine. The batteries work the opposite way round. So the batteries have a buck converter. So the battery voltage is higher and it drops it down onto the AC. And then when you're looking at the minimum battery voltage, especially if you're using them on the modules, the battery voltage has to be in a star configuration. You roughly it is 1.4 times your voltage. So if your voltage is 240 volts or 230 volts, it's 1.4 times your voltage times 2 is the minimum battery. And that's when the battery is at its lowest state. That's the lowest battery you can have. So if you're using a separate battery, you always have to remember that. If you're going in a delta format, the batteries can be slightly lower if you want, because it's 1.4 times the voltage. So if your voltage is 400 or 440 volts, whatever it is, then it's 1.4 times the battery times the AC voltage. That's in delta. In star, it's 1.4 times 230 times 2. So it's slightly different calculations. So the batteries are larger. Just very quickly showing different configurations. One of the configurations is quite interesting. This one. So this one is using a DC coupled. So it's where you have your PCS here, and you've got another PCS here. And so it comes in, it will charge the batteries, any solar will come in here, and it will output through the PCS onto the load. It completely isolates. So if you've got a very noisy grid, or if your grid cannot always supply the peak demand of the load, or if you cannot afford any risk at all, any interruption, zero interruption, nothing, this sort of configuration is quite nice. So it means that both machines are permanently running. You've got no changeover contacts, no nothing, but they're running into it, onto the DC couple, back out again. Any MPPTs will go onto the DC lines. The whole thing is DC coupled. We're actually doing a system. So we're actually installing, we're working on a system at the moment. We don't install it. We're working with a company in the Philippines, in a place called Iloilo, which I'd never even heard of before until I went. Nice place, but I went there and we were working with an installation company called Solar in the Philippines, and we're going to install probably the largest, best system in the Philippines, privately owned. So this is really, really nice what we're doing there. I did some video on YouTube about it, and we're now going through all the fine detail, but this is moving forward really nicely. And that's using the same thing. On that one, it uses transformers. The reason using transformers is because their grid is 480 volt delta. We can't handle 480 volt delta because the battery is going to be too high, your MPPT voltage is going to be too high. So we have to have a transformer. Got absolutely no choice. Some of the things people say is a myth. They say, we have to have a transformer because of big motors. Most of the time the transformers are there because of the conversion. Big motors is where they had transformers would tend to be on the low frequency inverter. So people used to have low frequency inverter. So you basically have a device that takes you 50 volts or 100 volts or whatever, 1,000 volts, converts it into an AC from a DC, and then it uses a transformer. It keeps it at the 50 hertz, uses a transformer and converts it that way. It's the old-fashioned way. That sort of technology has been around a long time, and so people saw transformers and say, well, this is the way you do it. The fact is, we really don't need a transformer, especially South Africa, you don't need it, but some applications you do. People ask me about motors. Generally, if you're going to a variable speed drive, you've got a big motor, it's outputting on a variable speed drive, it will make no difference. The drive will handle it, it will control it, regulate the power going into it. If you're going onto a big old-fashioned motor, then you have got inrush currents. sometimes capacitors that are there because you've obviously got a massive reactive inductive load on the motor, and you've got power factor correction things, and suddenly the inrush, it'll see almost a short circuit. And so you have to be aware, and you have to look at the inrush current. The inverters will take a certain amount of overload. By adding a transformer, it won't fix that problem because you still got to put into the transformer what you get out of the transformer. The only thing what I've experienced, it's so in Hong Kong, for example, we have to use transformers. All inverters have to be coupled with a transformer that's on grid. They produce lots and lots of wonderful harmonics, and the transformers create the harmonics. And people are not always aware of the harmonic distortion, but it's basically hidden losses. So you've got this THD, total harmonic distortion, is a massive, you lose a lot of energy and you don't see it. It's somewhere, maybe on the second, third harmonic, the 50th harmonic. And so those harmonics are caused by transformers themselves. You've also got your power factor, because transformers are reactive. And so you also have issues, power factor, and lots of problems. So generally, if you don't need a transformer, don't use one. The transformers we do include transformers on some of the stuff. The transformers we use, they are silicon steel. So silicon steel is a little bit different to the iron. So they're much more efficient. So if you look at the efficiencies of silicon steel, it's by far better than the old iron transformers. So moving forward, that's the power hub. That's actually, there's Lee hiding in the corner, our technical director. He's there. And this is what the power hub's like. This is from the background. So what I was showing you is people show ideas and they think, oh, it's a drawing. They're not, they're real. There's one on the way. There's a couple, I think. Neil, there's a couple on the way, isn't there? One? Two. There's two arriving in South Africa, hopefully for the show. Yeah. So Solar Storage Live, we'll be showing it. And so you'll see what it looks like. They do look good. They're sexy. They've got LED lights. That was one of the things. Let's put LED lights on. As engineers, say, why? Because some people like them. They do. I don't. So yeah.
So Keith, just if you speak about your inductive loads and that, if you have, sometimes you have motors in a facility that can't go onto a variable speed drive.
Yeah.
And in a case like that, if you use the transformer, would that assist in terms of being able to handle the inductive load, or is that a separate topic?
It would be separate. Yeah. If you put a transformer in, transformer's not really a reservoir, and you're going to be starting, depending on the type of motor. So a lot of those motors will be star delta. So you're going to be starting it with star delta starters. Generally, no. There might be very certain circumstances it might make a difference, but generally our inverters don't need it. They really don't need it. It's more, there are other reasons for it, but I know a lot of people talk about transformers, and if you want a transformer, we can supply a transformer. I'm not going to go here and convince everybody, but it's worth. I think what we'll probably do is, if we get the opportunity in sites where they've got sort of heavy transformers up to the rating of the inverter, it's worth testing, because we're testing it and showing it with the transformer and without the transformer, and maybe we'll do some video where people can see the difference, because I'm not going to convince anybody either way, but honestly, most applications you don't need it. Okay. So obviously we're talking about smarter approach. We think our product looks nice, and I'm going through this. So let me go through, this is what the units look like, and I'm showing this is into a container, because I think a lot of the time you guys maybe build your own containers, or we have what we call our indicator. So inside the unit we have and these particular ones, this cabinet is an MPPT cabinet. This one is your PCS cabinet, and each of the cabinets you have on them, you've got your EMS. Here you've got your master EMS, and there's also your battery EMS. Your battery banks are here, and then you can see on here, in fact these are marked the wrong way around, so actually that's actually a PCS, it should be the other way around. So here this is your PCS cabinet, and here is your MPPT cabinet. And there's a DC coupling unit that goes on each one. It's not shown on the drawing. There's a DC breaker that should be on each one. But I'm going to show you the real product in a second. So showing about when you start looking at the buzz bar configurations. So when you mount a cabinet, and I'll show this when you're mounting a cabinet, and if you're going to buy just the cabinets, you're going to make your own units up. You need to consider to get the back of it as well as the front of it, because if you want to change or upgrade or whatever, you need both sides. On our we call it indicator, which is our container solution. You can access both from the back and the front, all side opening doors. And also now we make all of our battery cabinets are side opening, so it's very easy to service.
This is the firewall section.
So you can see here, let me go back one back. Sorry. So you see here the bus bar configuration. So this is the bus bar configuration for MPPT. This is the bus bar configuration for the PCSs. A little bit different, and you can see here L1, L2, L3, neutral and DC line. And the same here, you've got your DC lines, and you've got these sort of nice configurations for the.
In prior document slide, you had PCSs and the MPPTs in the same cabinet.
So the smaller ones, up to 500 kilowatt, same cabinet, because over that separate, because you can't fit them in. And so what we're trying to do is have a standard cabinet. So if you buy the 1 megawatt cabinet, we're going to do it in like a skeleton, we call it a skeleton. And so basically it will have so many fitted, but it's got the space to fit more. And the same, and will all be pre-configured. So the IPC is connected by a comms cable. So each unit has a comms cable. And so the whole thing is controlled by its local EMS. And then that controls again from the master EMS to all pulls together. But when you look at them, they are quite complicated. But all that I'm trying to demonstrate on here is if you either use one of our complete solutions, you say, right, we're going to buy one as a complete solution, not so expensive, we want it all built up in a container, or alternatively, you turn around and say, okay, well, we don't want to do that. We want to build our own, which is fine. Our prices are very, very, very competitive compared to everybody else in the market. And I think our products, my opinion, which obviously, and I'm sure our competitors have their own opinions, but it is a very, very good piece of kit. Let me just quickly go through. So here, this is actually the PCS, and I show this as the PCS. So here you'll see, this is the breaker, this is your DC breaker. So each of the units have a big DC breaker in it. This is your AC connections. So in the PC cabinets, you've got DC and you've got the AC. On the MPPTs, you'll just have your DC breakers, and you also have your MPPT breakers. And so, but the all-in-one, you've got everything is in there, and so it's a little bit different. But this is the internal. Let me show you how it all comes together. So this is a video that I made for. This is a container that I inspected not long ago, and it was done for a customer in the UK.
So get you ready? Okay.
So I'm going to fast forward. It's actually for a company called it's a UK company. It's a UK company called City Electrical Factors that we're working with, and this one was for them. They are nice, and let me show you a little bit about it.
We actually use these are air cooled rather than water cooled. People have a myth and think, oh, the air cooled is just going to blow air in the batteries. Now it doesn't. The HVAC units actually use liquid. They actually use a liquid internally. So they use a liquid to circulate one side. So on here we have the in and the out, and this circulates. And on the other side, we circulate the air through. And it goes through the ducting of the battery, it goes through the ducting and it comes back out. The nice thing about doing it this method is we haven't got pipes and clips and water flowing everywhere. And quite frankly, in the UK, most of the time, it's cold enough anyway. We don't need a cooling system. You don't need to add the parasitic losses. This is nice. Each one of these packs of batteries.
So I'm talking about parasitic losses, where if you're running a cooling system 24/7, the amount of energy you're going to be drawing and using from it, where these systems, they use a liquid, obviously a coolant, so you don't take the air from the outside in. It's circulated internally, so it doesn't pull air through. It's a sealed system, and it's done it's coupled by a coolant, but we don't use water flowing through all of the electronics.
The battery management unit. Okay, so the BMUs are connected to here, and then let's show you how it all connects. Here you have the fire system. So you have the fire system. I've got a separate training video which is just done to show how the fire system works. It's dead simple. You just switch it on, connect the battery, job done. And then let's go around to the side. Come on. You've got more batteries. And again, there's the rest of the batteries. All accessible. Look at this, how easy it is. Simple, 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 simple. Okay.
So we actually have we make it all accessible from the outside. So rather than having to go into the unit now, we did do some units where you went in because of security. We felt the South Africa market, but now most people are fine to do it external this way, and this way gives you much more control, and you can actually access everything.
Wow. This is it. Wow. Okay. This got from an idea, and so here we have the cabinets are all nice and simple. So here we use the MPPT modules. You've got the MPPT modules here. Underneath here, we've got the breakers for the MPPTs. And here is the battery. So this is DC coupled. So the MPPT is DC coupled. The DC coupled to the PCS. So you see here, you've got the heavy DC cables here. These are high voltage DC cables. So you've got to be obviously very, very careful. There's the DC isolator. Let's close it. Oh. So here we've got the business end. This is the AC side. Again, every unit's got its own separate monitor. So on the actual PCS unit, we've got a separate monitor here, and this is the PCS. PCS is here. This one's got 4 PCSs. We can put more PCSs if you needed it later. We can put slave PCS. But this is the breaker for the DC side, which is the high voltage DC. This is the breaker for the grid. The grid simply connects to here. It is as simple as that. You've got an access point underneath here, you can see, and you can bring your cables underneath the unit, and you go to the access point. And if you need that trap, which is that hole in the floor, you can use that if you need to use that for accessing. So the whole thing is connected to a central EMS. And this is the central EMS. This is the Sunsynk EMS. This is what it's all about, isn't it nice? This is the Sunsynk EMS. The other unit up below it is actually the battery control. So you've got the battery EMS, the master EMS, you've got the PCS EMS, and the MPPT EMS. You've got every type of EMS. So here, they've actually left the antenna for the thing. Here, you will connect our data logger. This is the router. We connect our data logger to this. The nice thing about it is simplicity. We've got the fire system here. This is the suppression system, and it's sitting here. This is a piece of kit. It's lovely. Fuse board for all your lighting, for spare sockets, everything else. So the whole thing comes together. This is it. You've obviously got ventilation here because it will suck air through itself, but in fact it's got double filtration. So these filters are partial use service. You can remove these filters and swap them, but you've got filters for filters. You've got the outside filter, you've got the inside.
So I'll stop there. So basically, I'm trying to explain about the serviceability of the product. It's really, it might look complicated. That's a pre-built unit, but separately, it's the same modules. If you want to buy the separate modules from us, you want to buy a PCS cabinet, you want to buy an MPPT cabinet, you want to buy an all-in-one unit, you want to buy a separate transformer, separate STS, it's your choice. But they're the same items. So from serviceability, you don't have to have lots and lots of different things. You have one PCS, you have one MPPT, one STS. It's really that simple. It's it's a really simple solution. I tried to show a little bit about all our batteries. We have the separated, there's air gaps between everything. Everything is handleable, and I'm going to show you a little bit to show you the reason, because it is important. It is important to handle these things.
Can I ask you a prior question? Could you go back a couple of slides? I need to ask something. You had 2 PCSs in the one slide, separate MPPT. Was that basically making sure that you take your grid and you convert your grid to DC?
This one?
That one,
yeah. So that one is using a DC coupled system.
Okay.
So yes, it takes the grid, converts the grid to DC, and it takes it back from DC to AC. So it's a grid coupled.
All the time.
It's online all the time, and basically whatever goes on, whatever happens, the grid side, you're always going to get an output.
Is that the same PCS just reversed?
Yeah.
Exactly the same?
Yeah.
So if you consider the SSEG, small scale embedded generation
Yeah.
application, in an application like this, do you preclude the PCS bringing the DC in because your SSEG?
No, you have to. So no. So what you would do is this one would be the one for your application. So what size? So if
that's not bidirectional.
No, you can have it so it's non-bidirectional. So we can set it to 0 but you still have to include it because this would be the connection. It can be bidirectional. So this can be absolutely bidirectional. But if your grid, so it's depending on what you're allowed. So often what they allow you in is what they allow you out, depending on the grid connection. So it depends. If you've got a 500k connection, you can't put a 1 megawatt inverter on there because you won't damage a transformer, probably could do, but you're more likely to damage switchgear and you're going to trip things. So this is the nice thing about this. You might only have a 500 and you want a 1 megawatt, you need a buffer, then this system can give you that buffer. And also don't forget, you're going to be getting energy coming from the solar panels as well. So you might have a nice constant 1 meg out, depending on your solar array, whatever, and you're having a constant coming in, 500k coming in.
Yeah, so the reason why I ask is we got what we call a small scale embedded generation application that you have to put in with your municipality. Typically, if you've got a grid tied inverter and a battery inverter, they look at your capacity by adding the two together.
The battery and it. So
the grid tied and the battery inverter, they add those as your combined generating capacity of your facility.
right.
And it can't be more than 70% of your nominated maximum demand.
Right, so I don't know on that side of it, but all I can say is on the grid code compliance side, which is your physical grid that you can do, would be basically, so you obviously got your grid allowance, so many people will have a much larger battery, so you have you but obviously you're talking about on scale, so I don't know on that regulation, so I can't answer that. But the system will fall in, you can use whatever you want to use.
So what, like ATIS is an example, you might know them. They use a rectifier.
Yes, they do.
Your PCS, because everything that happens this side of the rectifier has got nothing to do with your SSEG.
Well, that was what was my question. So yeah, so you can do that way.
Okay.
So that can be done that way. Correct,
Okay,
correct,
good.
correct. So I know ATIS use a rectifier. We use the PCS because we just keep one unit, but you can have it zero export.
Okay.
So yeah, I'm aware they use a rectifier. And so I don't know your regulation. If you use a rectifier, does the regulation not fall under it?
It doesn't.
Right. Okay. So fair enough. So that's exactly it. That's exactly it. So yeah, I'm trying to sort of demonstrate a DC coupled system, and because of grid code compliance, what you can pull. But it's a really good example.
They refer to it as being, because in the ATIS world, there's absolutely zero way that you can get power from here to the grid.
Yeah.
Okay, so they can guarantee zero feedback.
So we can do that. We can do the same thing. So we can offer PCS with zero feedback, zero.
Okay.
You can use a standard one that can give you feedback. So if you say, okay, so the ones that with zero, you can specify, say we need a PCS with zero feedback, zero.
Okay, perfect. And then that's your rectifier effectively.
Yeah. For it to go back, it actually has to reverse. So if you have that function disabled, it can never go back. It's just a one way. So if you want to call it a rectifier, which basically I suppose it is in a way, it's a power control. It's a sort of rectifier. It gives you a bit, the way we've done it is it gives you a lot of control. Cost wise, it's probably the way we do it is probably more cost effective. I have no idea on the cost of the ATA systems. I can't comment on it. But basically, yeah, it could be
It's a big topic at the moment.
right.
Big topic, yeah.
Well, I'll show you something else in a little bit while, but yeah, no, I get it. And it's a similar thing what we've had here. So some people want to have the export, some people don't.
Great.
All honestly, so this particular application is shown with having the export. You can have the application with zero export, and if that's the case, if that's the regulations required, fine, you can do that. Not a problem. I'm not so familiar with it with the individual regulation.
Just to explore it, but we'll explore it together at Baptist.
Sorry, yeah. It's great to talk to these and have these move the videos forward now. But it's great to have these conversations because obviously, I'm learning as much as I'm showing for you guys. I'm also learning. One of the things, and this is obviously grid code compliance. I was at a function not long ago in the Philippines. We were talking star and delta, and I suddenly was introduced to about 5 or 10 different other configurations, because I always thought as an electrical engineer it was a star or delta, but apparently in the Philippines it's not. They've got lots of them. So they actually have a delta grid. Just so you know, they have a delta grid. So their grid is delta. So how do you think they get a neutral? They tie one of the ways. There's many ways, but one of the ways, they'll pick one of the delta, L1, L2, L3, they'll tie it to ground, and that becomes the neutral. And then they say, we keep getting inverters blowing up. They also have what they call open delta. And it took me a while to realize an open delta is actually just L1, L2, but actually it will actually give you phase rotation. But then when they tie the center, the point on the open delta to ground, it also has a problem. So it took me a while to click. I said, the only way you can do this is single phase inverters. You have to use single phase, because if you're going to ground one side of the single phase, you can do that, but you can't ground a point on a delta. It was interesting. So I learned, and they actually gave me a whole board with some of these guys in the Philippines, they're clever. They're really bright guys. And yeah, it was like bang, bang, bang. He said, what do you about open delta? And what's open delta? So I learned a little bit. You know, we talk about saving money. This is just an example, because obviously we do parasitic losses. You know, parasitic losses is because our systems don't need to run cooling systems continually 24 hours a day. We're not pumping water through it. You know, and we use air cooling. Generally, forced air cooling is much more efficient, and it's better than water cooling. One of the things, you know, some people say, oh no, it's got to be water, it's got to be in the desert, it's got to be water. Well, actually, it's not always true. And I talk to a lot of people who have major issues with water cooling. Condensation was one. You know, you've experienced condensation with water. You know, and water cooling causes condensation onto electrical circuits. Bang, things don't like it. I trained as an industrial spark. I'm a time-served electrician, and a long time, you know, I've got burns to prove it. Even when I was an apprentice, I caught my watch on a buzz bar, and my foreman said, "Well, you'll remember that. You'll be able to tell your grandchildren about that." And I think I was about 19 years old at the time. So yeah, so I've been through it. I've learned the thing. But parasitic losses is important. All of ours, we use coolants, but we use forced air. The efficiency of forced air is very good. And an example, be it right or wrong, a good example, I always say, if you've got a can of beer, and you know, here I like in South Africa, I like Vintage draft of beer. You know, I do like beer, and you put a bottle of beer or a can of beer in the refrigerator, and then you go in the room, you switch your AC on. Which is going to cool faster, the room or the can of beer? The room, obviously. The air cools faster, and the systems work very well. And so we do this way. So I go on about that.
Your 2,200 watts, that's to cool the water, is that what you're saying?
So this was comparing with a water cool. You know, I was in Hong Kong, and I saw a system in Hong Kong made by a competitor, and they actually had a generator running 24/7 to keep that, because of the parasitic losses. So they had a generator with the container to compensate for the parasitic losses. They're so big. People don't get it. They think, oh, it's all about price. They forget these things. This is just one example. This is on a power hub. This is not on a container. On this, it's going to be much bigger. So you're suddenly, you know, you're suddenly wasting hundreds of thousands or millions of rand from going down the toilet just because it's running. It doesn't need to run. And you know, cooling is an interesting one. The inverters themselves is forced air. That's always going to be the case. But for batteries, of course, it's important to have stability, because you want to keep your cells at the same temperature. It's important to keep stability. But sometimes when the weather's not so hot and there's no sunshine, you don't always, you know, how many guys you fit battery systems and you put them in an air conditioning room, or you just leave them just as they are? Don't have a problem. You know, but sure, on the big stuff, you need to make sure the batteries they're regulated, they're monitored. So we will have a blowers running through it, but if the air needs cooling, it will switch on. So it's very efficient way. It's also maintenance-wise, it's much easier. So I was talking about grid code compliance before. So this is actually in Hong Kong, and we were actually discussing about. So and we were actually talking about in Hong Kong. And this is some of our team, and we were discussing about the benefits, and we were saying one of the guys is a consultant, the rest is actually our Sunsynk staff. We were actually going through training ourselves, and I was asking one of the questions. And so definitely not. Yeah. Because of the problems and too many issues.
issues, and the efficiency also is not very high in the very hot temperatures.
So liquid doesn't work well. So that actually. So one of the things they say is liquid is better in a cooler environment than in a warm environment. Liquid doesn't. Forced air is better. I argue with people because I know some people, they think, oh, it's all about liquid. Liquid's got to work the best. And, you know, most people in this room know that. And most people I come across know otherwise. But I also, unfortunately, not everyone agrees, but this is... Yeah, so he's expert in C&I. And you're also saying the problems you've had with liquid as opposed to... So Lee used to be working for one of the major manufacturers. In it, or what is the liquid? What's liquid that's used?
Probably glycol based, no? Glycol?
The glycol?
Yeah. How to say? For liquid, there are so many kinds. Such the simple coolant is water, pure water.
So I always mention that, and then I'll because the most important thing about our range, and I'm going on about it, is the serviceability and ease of use. Because, and then let me show something else. So I'm going to flick through this. So this is actually sort of a training, team building thing that we were doing in Hong Kong. And we were looking at batteries and assembling and replacing batteries and how to replace a battery. And this is actually, most people, you guys are familiar. It's probably weighs about 160 kilo. Wow, first one in.
You just went for it, and I was like, he's doing it.
It's so easy. Not. So we're basically fitting batteries in with a small hand pallet, and 2 people can take it. That's the heaviest thing in the system. That battery is the heaviest thing. If you can do that with 2 people with a little truck, all of our systems can be maintained. So it means if you've got to go out, if you have a problem ever, you need to change a battery pack, small truck you can put in the back of a buggy, and 2 guys can swap any of the batteries. That's not a problem. When you compare likes of this is big battery that I came. You know, there's a lot of manufacturers making these huge batteries. Can I ask? I'll ask a question. It's a big thing. This probably weighs it's the weight of a car. It's the weight of a car. I've seen them assembled into some of the containers. Amazing. They've got these huge machines with massive hydraulics, and these things can pick it up. And you've got to keep up. No people are allowed in the area, and they can push it in. It pushes it into the unit. Absolutely precision. Amazing machines. Ask a question though. It's all then plumbed in with all the plumbing and the cooling and everything else. What happens? In 5 years later, it goes faulty, and you get a call off your customer and say, it stopped working. I've got a problem. I've got a temperature. I've got a warning come. What do you do?
Yeah. Throw it away.
The container. How do you get that out of the container? I don't know. I've asked the question to people. Say, well, we have some specialist equipment. Yeah, okay. What do you have? Because you can't put that. You can lift it with a heavy-duty pallet with a heavy-duty fork. But I don't. How are you going to get it out? You're going to drag it out, a couple of ton. I don't know. I have no idea. I would love to find somebody that can actually physically do it. And I showed the other one because I did with our own staff. I said, this is what a battery feels like, 160 kilo, or maybe up to 200 kilo, which is heavy. It is heavy, but it's manageable. They can do it. You have to take care. You obviously go take all the safety precautions, everything else. Have some experience. You can do it, but that I don't know. I have no idea. If anybody could tell me, I would love to know. So we're finishing on. This is our call center. So this is our call center. I'm showing this to show you we support our products. So everything's supported. We have lots of ways of supporting things. And so this is actually in our Tenerife. And I'll show you this. We have got other call centres around the world. We have got call centre in South Africa. We've got in the UK and Philippines and India. So we've got a few others. But this is sort of the central hub of the call centre. This guy supports an amazing football team. It's a great, amazing football team. Liverpool, which is my team. Yeah. So and then we lost last night. Sheena. This is Sheena. So I did a training video recently. So Sheena is the head of the what's it? How is it? Call center.
Call center.
So tell us a little bit about. She wasn't.
How's it going today anyway?
Good, yeah.
And how about queuing? Are we catching
We've
all
got
calls?
really good system, yeah. We've just got one waiting in the queue at the moment. We've had about 150 calls this morning so far. And out of that 150, we've just got one waiting. So yeah, really good response times. We started this on Friday. Response times, resolution times are getting quicker. Tickets are getting answered a lot quicker as well. So our stats are really proving well, and that's what we think.
Well done, well done. And we listen to these guys. You see, we have many different languages. So,
y para que obtener esta luz normal en el inversor.
I have no idea what he's saying, so I can't comment. So these are some of the guys on the call centre, and we now aim to handle all.
So I show this is because we do the support. We have support in lots and lots of ways. So we have a central call centre, which is in a place called Tenerife. I'm not sure if everyone knows where it is. It's basic. Okay, so everyone asks the same question.
Because it's a volcano island.
It is. Yeah, it is a volcano island, but it's okay. It's a long time since it erupted, but it's pretty well in between. I think we're pretty well halfway in between the UK and South Africa. It's pretty much in the middle. It's off the Western Sahara. They have absolutely amazing internet connection because the cables probably that's coming into South Africa come right through there. So they're actually probably terminated in Tenerife and in Cape Verde and some of the other islands. They'll terminate them through.
I'm from Gran Canaria. So
Oh, you're from Gran Canaria?
yeah,
Okay.
my grandparents are.
Okay, fantastic. Okay,
that's why I
so
was asking.
one for you, so you know it. Okay, so we operate there. Tenerife has a lot of call centres. Maybe because they've got people of many languages. It's very easy to get various languages. There's a lot of people with a lot of experience in call centres. So basically Tenerife, call centre or bar work, and pretty much that's it. And it is, and so we operate there. It works for us. We've got a great place. We've got a great team of people. The place is actually a full branch. So we have a training school there, and we support Spain. So we have the Spanish training school. We supply locally to all the distributors from there. So there's a lot of things we have going from there. So it's really, really good. We do support from our unit. So if you use the Sunsynk Connect, the Sunsynk Connect on the app has a built-in help, which is real people, 24 hours a day, 7 days a week, multiple languages, run by people, not AI. I don't think a lot of people realise that. And we do support. We are going to be introducing, and then maybe Neil will explain a little bit later, that we're going to be introducing a dedicated WhatsApp number. So rather than going on a forum where you share all the information with everybody else, we're going to have it will be a private number, and it will be manned 24 hours a day, 7 days a week. It can be manned. If you want to ask questions, you want to do something, it's private. It will take through security, and it's completely private. It complies with, you're not having to publicize anything about your products on a public forum. And that's really important. And if you want an upgrade, you can either teach you how to do an upgrade yourself, but if you want the staff to do it, during the normal daytime of South Africa, it's pretty well covered because Tenerife's open about the same times. And then out of hours, weekends, it covers from the Indian office, which is running there. And they actually run 24 hours. So if you have the desire to be actually working on a system at 2 o'clock on a Sunday morning, then and you want an upgrade, it can be done. It can be done. And I don't think many people can do that. So it's quite important. Going forward, this is actually a video that was just talking about so I'm obviously talking now, moving a little bit away from the LK range and just showing, because obviously we have our LP range of inverters. This is what
new technology, enhanced technology.
They made it, I think, more simpler and friendly user-friendly.
Durability.
That process,
Bali nag-upgrade kasi sila, yun ang maganda lang. At the same time, siyempre yung mga competitors nag-upgrade din. Kaya lang, meron sila mga special features bukod dun sa mga existing nila. Kasi develop nila
the innovation of improving something. That's because we improve everything.
So I'm showing that is because, you know, in the Philippines, they've got huge power problems. Those guys on there, they're part of a solar association. They are actually really the top people. They're some of the top people shown on there, and they're good, you know, different environment. They've got power problems, and they're looking for a product which is ultra reliable. We've launched in the Philippines, and this is the sort of feedback we're getting. It's really, really good. So I've got a few things left to show, and I'm going to go on to show you a little bit about our LP range, our Links Professional, and to understand where we're coming from. This is a short video, and it's to show you, and I use some videos because it's easier for me to show on video rather than actually go through and bring all the products. There's too many products. So this is action. We're here at the test facility, Sunsynk. All the engineers you can see are working hard. We're actually testing our inverters. There's lots and lots going on at the moment. So let's talk about this, and we'll talk about internal training. In fact, there's a blast from the past. It's a product we used a long time ago for South Africa. This is it. This is it. This is actually a three-phase, 12 kilowatt MPPT, 9.6 kilowatt per MPPT. It's got two trackers. Each tracker is 26 amps, so it's massive. It's a massive amount of power. So and this is actually, it's not oversizing the MPPT. It's an actual MPPT. So it's beautiful. Three-phase. It's got the new UI. It's Texas Instruments TI chipset. It's fully loaded. It's got everything in it. It is very, very nice. Does it look? It looks really sexy. It's a really, really nice piece of kit. Perfect for European three-phase market, German market. If you actually look here, this is baby brother. So this one is so the actual back one there before was actually the 12. This actually, it's a prototype. It's actually in test at the moment, but it'll be ready very soon. We can actually take orders. So this unit is a 8 kilowatt, and we also have a 6 kilowatt three-phase. So we've got 6 kilowatt three-phase and 8 kilowatt three-phase. And this unit, you can see here, uses the Sunsynk UI. It's really, really nice and sexy. It's really nice. So simple, quick control, quick settings. Everything very, very simple, very, very simple to use. System flow, you can see the system flow. Isn't it nice? Lots of things going on. Look at here, on this one, actually, you've connected this to the Sunbat. This is Sunsynk 16 kilowatt. I'm dropping something. This is a 16 kilowatt battery. It's on wheels, 16 kilowatt hour, I should say, and that's connected to it. Everything is plug, play. So it's really, really quick to install. Look at this. Look at this. Look at this beastie here. Look at this one. Wow, this is a 12 kilowatt single phase. It's IP42, however, it's got some nice new features. If you look underneath, we've got 4 connections. So in fact, we actually have 4 different outputs on this. So rather than having a generator port, and you can see on it, we've got an auxiliary, we've got a generator, we've got a load, and we've got a grid connection. 4 connections. It's nice, it's really nice. Using new UI. Not so expensive. It's designed to be value engineered is the best way to see it. And you can see this is a really, really nice piece of kit. What's this battery we've connected to, Phil? So this is an X Series 5 kilowatt hour we've connected to. So you see some of the different batteries that we have, and as we've been developing in the past. Come and have a look at this. Lee, this is the Hyper Gateway. So we've connected the Hyper Gateway. This is connected to a. Is this a 6? This is what size inverter is this?
That's a good question.
It looks a large. It's not.
It's one of the 6 on your.
So this is the Hyper Gateway for whole house backup, but it's different.
So the Hyper Gateway is very, very nice. We set out to develop this product to do everything. It does absolutely everything. So about the Hyper Gateway, explain a little bit about the Hyper Gateway.
Okay, so on the Hyper Gateway, we've pretty much designed this to allow whole home backup, where somebody can have their UPS loads and the essential loads connected, but also have the non-essential loads connected when there's a power outage. And by doing that, we've got a load 1 and a load 2 terminal out here. Also, we've added the nice feature of a gen and a grid connection in, so people can connect both systems to the Gen Gateway, or the Hyper Gateway, sorry, and you can control either the generator or the grid to be on.
So you've got every connection you ever need. And for it to operate a generator, it's so simple. You've got, this is for the ATS, the generator.
Yeah.
And it's really, really simple. It's a whole house backup. It's rated as 80 amps. It's 80 amp per channel, so it's 160 for it makes we rate it 80 amp. But it's basically designed as a whole house backup. It marries perfectly and it runs from the UI of the Sunsynk Connect. I've got Sunsynk Connect in the brain. The second, Sunsynk second generation, it runs with the UI from the second generation and it's fully programmed from here. Is there anything on the UI that you need to be aware of?
Yeah. So when you want the system to work with load 1 and load 2 in the essentials, we'll go back to the start, you'll come to this page in the settings, and then over here we have a gateway function. This will enable load 1 and load 2 to activate when grid's lost.
So we've patented this, so it's a really nice feature. So we've actually patented the product. So we're actually doing, you see here we're doing... So I'll stop at that point. That product is unique. It's absolutely unique. And we've got a couple of unique products. The beauty of that is we call it Hyper Gateway. Is old-fashioned way you have your essential loads, your non-essential loads. Your non-essential loads, you're on the AC coupled. And if you have a power outage, and okay, maybe there's no more load shedding at the moment, who knows what's going to happen with oil prices. And I'm still noticing I think you guys have got 2 huge diesel engines that run. And how many millions of litres a day they use, 2 diesel engines, which basically supply a lot of power. If those, at some point, if the problems are the price of fuel raise, I don't know. Maybe it will come. Maybe the government choose to switch them off. Maybe they choose not switch them off. I have no idea. But if it comes, the beauty of doing this is it can give you a whole house backup. So in other words, if your power is on, obviously normal, okay? If you have a power outage or whatever, or power cut, and power cuts do come. If we get load shedding, we get power cuts. We get it in the UK. It does happen. Maybe due to weather, due to lots of reasons. But if you have a power cut, and the inverter is, say, argument's sake, 8 kilowatt, and you're drawing 12 kilowatt of power, what's going to happen? The inverter's going to trip if you're taking the whole house through it. So basically, the whole house is being fed, the unit will trip. But then what happens is it will reset automatically, and it will come back on again. But it'll come back on again with just the essential. The non-essential will cut out. So it's got 2 outputs. If your load on the non-essential is lower, so your total load is lower than the rating of the inverter, it won't cut. If it is greater, it will cut the non-essential off. And then if you come back, you come back and you can press the button. So 1 or 2 reasons. One, if the grid reappears, then if the grid reappears, you're back on and it will just automatically connect. If the grid doesn't reappear, and if you then switch certain things off, you press the button and it connects everything. And that gives you everything in your house being powered. So you've got 2 channels. That we patented that. It's unique. And it's a very, very nice feature. I'm almost full. This is showing we've got a 125 kilowatt inverter coming. It's just in the R&D stage. This is a true hybrid. It's a true 125 kilowatt. It's not a string inverter with a DC stage. It's a true one. So there are some products coming on the market which are actually string inverters, and they have a DC stage onto a string inverter and call it hybrid. I'm not going to mention it, but some famous companies do that. This is a true, absolutely true. It can export, it can import, it can do absolutely everything. It's a true hybrid. This is 125, it's got 10 MPPTs, 200 kilowatt of MPPT, all in one unit. It will be available very soon in South Africa. It's just going through the NRS at the moment.
And those, your 125s, can you parallel?
Yes, yeah.
Also using a type of STS or just like a normal AC combiner cabinet?
Just an AC combiner cabinet, you don't need a separate STS.
Okay.
It's already in it. So just parallel, same as your parallel 50.
And agnostic of the battery, you can use any battery
on it? It depends. I can't say you can use any battery because...
what I mean is that you can use like an advanced battery or do you have to buy a Sunsynk battery with your 125?
There will be batteries that we can specify. Of course, we want to sell Sunsynk batteries, but there are We will confirm a list, so I can't say that. I can't say it'll work with any battery. It's impossible to say that. And I think any manufacturer would be stupid to say, yeah. But not necessarily. So that we will publish a list of what it can be used for. So I can't really comment.
And still, you've got 2 battery channels.
Yeah.
So still no common DC bus in the hybrid inverters.
So on our PCSs, a common DC bus.
That's it.
So they can be common DC bus or single DC. You can do it either way. So on the PCSs, you can have them separate channels or common DC bus. So it can be run in either way. On these ones, it's a little bit different, but we'll give it. It hasn't released onto the market yet. It's about to. This is from the R&D, so it's very close. And I won't place it. I'm going to jump finally because David's going to present his stuff. I'm going to present. This is a product. You think, oh my God, why are we showing this? It's an old. It's a 12 kilowatt hybrid. A few years ago, everyone was amazing, but it is actually it is a rack mount 12 kilowatt hybrid. It has a very interesting feature, and besides, it's got a generator connection, it's got an auxiliary connection, it's got a load connection, and obviously the battery connections, and it's got everything else on it. But one of the major features of what we're doing for